Hello guys, so I'd like us to look at how to go about getting the solution of this second order differential equation given this using the undetermined coefficient method. Now, for a second order differential equation, now obviously since we've been given the constants, whatever we are getting is the general solution and not the particular solution. So to get the general solution, we take the complementary function plus the particular integral. So the general solution is given by the complementary function plus particular integral. In our case here, I'll call the complementary function yc, the particular integral yp. Now let's get the yc. How to get the yc? We first get the auxiliary equation and solve it. Now, for the auxiliary equation, let d2y dx squared be equal to m squared. Let dy dx be equal to m. And let y be equal to 1. And f of x, that is the right-hand side of the equation, be equal to 0. So if we replace those values in our equation, we'll have m squared plus 8m plus 15 is equal to 0. So m squared plus 8m plus 15 is equal to 0. Then we solve this using the quadratic formula to get the values of m. Now, note the values of m are what are going to determine how exactly we write our complementary function. So the values can either be real and different, real and different. The values can be real and same, like 2, 2. The values can be complex. So for each case, there's a standard way of expressing your yc for each of these cases. Now, if we solve this equation here, we get that our value of m is equal to... So clearly, our values of m are real and different. Real and different. So for real and different, yc is given by a exponential m1x plus b exponential m2x. So in our case here, our yc will be a exponential minus 5x plus b exponential minus 3x. This is our yc. Now, a side note here, for just in case maybe your m was probably real and same or complex and you don't know how to go about expressing your yc. For real and same, that is something like 2, 2. This is how you'd have expressed your yc. For complex, that is, let's say 2 plus 3j. This is how you'd have expressed your yc, where alpha is the real part and then beta is the complex part. Okay. So let's continue to get our particular integral. Now, to get the pi, we consider the right-hand side. That is the f of x. Now, what is our f of x? Our f of x is a polynomial of degree 2. It is 2x squared plus 4x plus 5. 2x squared plus 4x plus 5. Now, note, depending on the values of f of x, there are ways to express your assumed pi that will help you get the real pi. So for this polynomial of degree 2, our assumed pi is ax squared plus 4x, plus bx. Ax squared plus bx plus c. That's our assumed pi. This is what we are going to use to get our pi. Ideally, what we need to do is evaluate and get the values of a, b, c so that we come and write our yp here without the constants. Now, how are we going to go about getting the pi? After we've identified the assumed pi, we are going to differentiate, get the first derivative and the second derivative, and then replace in our main equation. That is basically the question that we were given here. Let's call it equation number 1. So I am going to get dy dx. Differentiating this, we get 2ax plus b. then get the 2y dx squared, second derivative. This is going to be 2a. So replace these values plus the value of y in the main equation. Our main equation, you can recall we had the 2y dx squared plus 8 dy dx plus 15y is equal to 2x squared plus 4x plus 5. So the 2y dx squared is 2a. 8 into dy dx is 2ax plus b plus 15y. And our y here is ax squared plus bx plus c. This is equal to 2x squared plus 4x plus 5. So what we do now is we're going to open this up, then solve, basically compare it to this side so that we're able to solve for a, b, and c. So I want us to put all the constants together. We will be equating all the constants to our constant on this side, which is 5. So we have 2a plus, is there a constant here? Yes. 8b plus, is there a constant here? Yes. 15c is equal to 5. Call this equation number 2, since we already had 1. Now, let's get all the values that have x. So we have, this is 16ax plus, we have 15bx. And this is equal to 4x. Call this equation number 3. Okay, so I want to write this in a better way. We can factor out the x on both sides so that we have 16a plus 15b is equal to 4, which is much better. Now, let's get the ones that have x squared. So we have this one, which is 15ax squared. 15ax squared. This is equal to 2x squared. So the x squared and the x squared cancel out so that we have a is equal to 2 over 15. If a is 2 over 15, we can replace, so let's call this 4. So we can solve this. These are 3 linear simultaneous equations. We can solve them to get the value of a, b, c. Now a is 2 over 15. We can replace its value here to get the value of b. So I have 16, 2 over 15 plus 15b is equal to 4. And after getting the value of b, replace here so that we get the value of c. So solving this, if I replace this value of a in this equation, in order for me to get the value of b, this is what I get. And then if you replace these 2 values in the first equation, then you get the value of c. So we already had our assumed yp. So our yp will just be the same, but now with a, b, c replaced. So our yp will be equal to 2 over 15x squared plus 28 over 225x plus 2.7422. That will be the value of our yp. Now, remember, we said that the general solution is given by CF plus PI. We already got our CF, so our CF, if you come back here, was this. So I'm going to write it down here. Our CF was y is a exponential a exponential minus 5x plus b exponential minus 3x plus pi. So pi is 2 over 15x squared plus 28 over 225x plus 2.7422. Now, this is a particular solution. However, what we want is the general solution. The general solution, we have to get it by getting the values for A and B. So what we are going to do is we are going to use the given information up here. We were told that when x is equal to 0, When x is 0, y is 1, dy dx is 2. So let's start with when x is equal to 0, y is equal to 1. Let's first of all input these values and then we do the other one. So when x is 0, y is 1. Now this is our y. It's the particular solution. When x is 0, y is 1. So replace y is 1. Our x is 0. So if we put 0 here, this is going to give us 1. We have A. If we put 0 here, this is going to give us 1. We'll have B. So x is 0. If we put 0 here, we have 0, 0, and then we have plus 2.7422. So we can call this equation number. We had gotten to equation number 4, so we can call this equation number 5. Now, let's replace that. When x is equal to 0, dy dx is equal to 2. That was the second condition. Now, we need to get dy dx. This is just the value of y. So in order for us to get dy dx, we're going to differentiate. So dy dx is equal to minus 5a exponential minus 5x minus 3b exponential minus 3x plus 4 over 15x plus 28 over 225. So that's the derivative of y. And we have that dy dx is 2 and x is 0. So if you replace 0 here, this gives minus 5a. If you replace 0 here, this gives minus 3b. 0, and then you have plus 28 over 225. This is equation 5, so let's call this equation number 6. So this is going to be our, if we solve this to this and this, we're going to get the value of A and the value of B. And those values we come and replace here, and that will be our general solution, having the values of A and B replaced with their real constants. So that's how we go about solving that.